When we started talking about absolute value inequalities, we looked at two different kinds. We looked at the absolute value of x is greater than 2, and we looked at the absolute value of x is less than 2, right?
Right.
Those are the basic ones. When we started looking at the more difficult ones, we looked at these to help us to understand the process to do the others. And so when we looked at the greater than, we saw on the number line that if this is 0, we saw on the number line that the absolute value of what numbers are bigger than 2? Well, there were two situations. Any number bigger than 2, and what else?
Any number less than negative
Any number less than -2. So then we said, well, that's a situation where we have two intervals. So when we read this, we said the solutions would be, in terms of an interval, it would be -infinity to -2 union 2 to infinity, right? Okay, so this would be an R statement. So when we looked at a more difficult problem, let's say we had 2x minus 1 is greater than or equal to 5, you're supposed to use this fact to help you. So with a greater than absolute value inequality, and by the way, the absolute value must be by itself, correct? Okay, the absolute value bars have to be by themselves. So with this case, you would then say, the way we did this was that what's in the inside, that expression in the inside is this right here. For this part would be x is less than -2, or x is greater than what? 2. So what's in the inside, this expression, you just rewrite x is greater than 2. So over here, I'm going to say 2x minus 1 is greater than or equal to what? 5. Not the absolute value of 2x minus 1. When you rewrite it without the absolute value bars because it's no longer a true statement. Mathematically, that's incorrect. So once you get the absolute value by itself, you rewrite it without the absolute value bars. There are a couple of you that insisted on putting absolute value bars. Well, it's mathematically incorrect. So greater than is what kind of statement? An R statement. You had that idea in Math 98, 2 semesters ago. Not last semester, but 2 semesters ago. You solved inequalities. Not absolute value, but inequalities. You had or statements, you had and statements. So the next part would be r 2x minus 1 has to be less than or equal to what? -5. And then you solve each one individually. So you add 1 to both sides. You get 2x is greater than or equal to 6. Then what's the next step? Divide by 2. And if this was a -2, you would divide by -2, right? What else would you do? Yeah, and some of you are forgetting that as well. All right, now guys, on that first test, you want as many points as you can, okay, on that first test. Because there are 2 others in the final. So you divide by 2, so I get x is greater than or equal to what? 3. So the solutions to this inequality right here, to this absolute value inequality, would be any number that's greater than or equal to 3. That's one part of my solution. It's not the only one, because the other one's here, whatever this is. Add 1 to both sides. Combine like terms, I get 2x is less than or equal to a -4. Divide both sides by 2. I get x is less than or equal to a -2. So in terms of your number line, here's 0, here's -2, here is 3. So this says that part of my solution would be any number bigger than or equal to 3, right? So bracket over here, bracket 3 to infinity, and over here it would be any number less than or equal to -2, just like this. So then as in interval notation, you would say -infinity, parentheses, to -2 with the bracket, union, bracket 3 to infinity. Now let's talk about the less than. When we start talking about less than, we look at the number line. We looked at the number line. We said that the absolute value of what numbers are going to be less than 2. Well, that's where we saw that the solutions would be any number between 2 and what? Negative 2. So this idea right here. So a less than for us for this particular part for first test, let's say, the solutions are going to look like this for a less than. But your work has to match this. If your work doesn't match this, it doesn't matter if your answer is correct, your work's incorrect. You just happen to get the right answer by happen chance. Okay? So if you look at this, then that means that all of my solutions are between 2 and what? Negative 2. And that's what it looked like. That's how we did a less than. We did a less than with this compound statement. One of the worksheets you turned in today was things that look like this. So basically the idea is this. If you have a less than, absolute value less than, you take this expression right here that's inside the absolute value bars, and you write it as this particular compound statement. Now, one of the things that you saw in 2 semesters ago was this. There are a couple of you that want to somehow rewrite this to make it look like this. Okay. You can. You better use the word and, because this is an and statement. This is what kind of statement? Are. So you better say x is less than 2, and at the same time, x has to be bigger than what? Negative 2. That's an and statement. This is an are statement. An and statement means intersection. An are statement means union. That's why you see this union right here. That's not the way we did it. We didn't do it that way. Some of you want to make this look like this, and so you're getting confused with this whole process. So when we look at this example here, let's say we had 2x minus 1, same one, is less than or equal to 5 this time. So less than. Let's do it the way we did it. So the way we did it was now remember the absolute value is by itself, right? So once it's by itself, you're going to rewrite it without the absolute value bars. So this is a less than. So you're going to say this expression, you're going to follow this one right here. You're going to make it look like this. So that inside expression has to be less than or equal to 5, and at the same time has to be bigger than or equal to what? Negative 5. That's an and statement. Then you get x by itself. Negative 4 is less than or equal to 2x, is less than or equal to 6. When you do the worksheet, if you looked at those examples we did in class, you would have seen that with the less than, that's the way we did it. We didn't do it any other way. Then divide both sides by 2. You get negative 2 is less than or equal to x, is less than or equal to 3. So the solutions to this absolute value inequality would be any number between negative 2 and 3, meaning this. Close circle, bracket on both. That right there. As an interval notation, it would be bracket negative 2 comma 3 bracket. Now, that same problem, I'm just letting you know, if for those of you that attempted to do the less than with 2 separate inequalities, then this is what I expect you to write, is what I'm about to do. So it's up to you how you do it, but make sure it's mathematically correct to get the full credit. So you can use this idea here, that and statement. I got to see the word and, because and means intersection. So you would say 2x minus 1 is less than or equal to 5, and at the same time, 2x minus 1 has to be what? Greater than or equal to a negative 5.
You also used upside
No. No. So add 1 to both sides. So 2x is less than or equal to 6. Divide by 2. That means x is less than or equal to 3. So if you recall 2 semesters ago, what you did with an and statement was you draw 2 separate number lines. That's what you did. So this is 3, bracket to the left. Then let's do this one. You add 1 to both sides. 2x is greater than or equal to negative 4. Divide by 2. X is greater than or equal to negative 2. So here's a graph to this solution. Negative 2, bracket going this way. But I'm trying to solve this inequality right here. I'm trying to solve this compound statement, this and statement. What do you remember about an and statement? What word should come into your mind? The word that should come to your mind is intersection. So you may recall, some of you may recall, depending on how much you did this. That's why the two graphs intersect. That's the intersection. And means intersection. So then you did this. You said, all right, then my graph, my final graph then would be from negative 2 to what? 3. That is mathematically what you're supposed to do if you split it apart. That's why I didn't do it that way. So I'm letting you know now. Either you do it the way I did it in class, okay? Or if you insist on breaking it apart for an and, then I need to see this. Is that clear? Okay. All right. So that's a quick review of the absolute value inequality. You are going to have one. I'm not going to tell you which one it is. It's either less than or greater than. Okay? It's one of those. They're 10 points. Okay? All right. Okay, now, so that was a quick review on the absolute value inequality. Notice though, and I told you at the beginning when we did this, I said you need to have these two in your mind, right? Didn't I say that? So some of you are going to struggle with the absolute value inequality. It's something that's not easy for students, the concept. But if you have this in your mind, if you take the time and write out these two, then the rest is straightforward. And I told you that. All right, now,